Okay, we're going to go ahead and get started. I'll hand back the exams first from so last Wednesday or Monday, whenever you took it. Miriam? No. Well. What I did, the test ended up being out of 52 points, which I make each test worth 100 points. So what I did is I just multiplied whatever score you got by 2. So if you got over 50%, and there's some extra credit, I think you could have got up to 55, maybe 56, but you currently got over there. So I just multiplied by 2, so it's quite possible to have over 100 points on this. But basically, if you take the top score, multiply it by 2, you'll get your score that's in the grade book. And I also updated homework scores, and I realized I had wrong points for the first few. I was doing out of 50, and each of the units should have been out of 36. So I adjusted that and kind of went off your other exams. So take a look at that. If you've got exam scores, you've probably got scores now for the homework in each of the units. So those should be updated. I also realized I was only giving the exam scores out of 70 points. So I changed it. So those are, the previous two are out of 100. So I just took whatever percent you had, added those as points. So as of right now, if, let's see, put this down, just to, we'll make this sort of our word of the day. The total points possible, or that everything's out of, is 588 points. So if you got more than that, that's great. You've got over 100%. There's a number of you do, because there's also extra credit that you could have gotten. The attendance quizzes count like 1 point each, and those are all extra credit actually. So there's some extra points you could have. But if you had 588 exactly, that's 100%. Anything above that's more, and percentage-wise. So I did fill in. I've got a current grade listing, which I did put a letter grade. That just means if I had to assign them today, that's what you would have. Don't pay too much attention to the percentages because I go by points. The percentages are not weighted percentages, so they're not as helpful maybe as in other classes, but just look to that final points. Remember, the whole course is out of 1,000. So as soon as there's actually someone I saw had like 700 already. I don't know how they did that, but that's great. They've actually already got a C in the class. If they did nothing more, they'd have a C. But we got some other opportunities. We've got another, and it'll be a take-home exam for another 100 points. That's coming up. And then there's 2 units, so another 36, 36, 60, 72 points. And then the final exam itself is worth 200 points. And again, what you need to get on that final just depends upon what you're shooting for that final grade. 700 points is a C. 800 and above is a B, 900 and above is a A. Okay.
say that, like on the score that you wrote here, to take the top score.
Yeah, take the multiply by 2. So that, yeah, double it, and that's what's in, should be what's entered into the grade book. Yeah.
Will you be doing the homework for these 2 lessons the same way you've done it?
Yes.
So you get an A on it?
Yes, I always do that because
Yeah.
if you, I just want you to feel the freedom to study so that you learned it, and if you can show by doing it that you did, that's great. There'll also be a practice test, and I'm going to, as we go through the content today, you're going to see, I think the content for the test starts about 9.5. So we'll go over some of the beginning stuff, which gives you some background, and will help you down the road when you're taking calculus and beyond. But as far as the test, they won't be on the test. So we'll go over it kind of lightly, and not, you know, if you've got questions, we'll slow down and we'll take the time. But I just kind of want to give an overview, kind of get us to 9.5, and then we'll have the rest of the time to kind of get a quick start on 9.5, and then Wednesday we will just spend on 9.5, and I'll take some exam type questions. In fact, I will even have the take-home test ready for you so that you'll see there's like, I think there's 5 or 6 questions out of this section on the take-home test. So you'll be able to go ahead and start it. I think the take-home test actually is already in Canvas. It might not be active, but if it's not, I'll activate it. So you'll have a practice test and the take-home test that you can start on. Next week we'll do 10, and we'll do it kind of the same way. The first day of 10 will be some background information that will be helpful. We'll get to the point where I'll focus, this is the stuff that's on the test, and then we'll have Wednesday to kind of, as more of a work day, to go through some of the problems. The following week, so we're going way out, so next week we will finish all the content stuff. After that, then you have your practice test, you have your take-home test, you'll be working on it. The following Monday is really just a work day to come in and get help if you need it. If not, you want to work somewhere else, that's fine. But there's really not any content presentation. The Wednesday after that, actually I'm going to be out going to a conference, so it's going to be a work day. I do have a substitute who will come in. I think, was it a man or a woman last time that you? Woman. So this time I got the man who did the earlier one, the later one for me. He's just going to take my whole day for me. So he'll be here to assist you if you know, again, no new content. It's just working through the practice test and the test. And I have instructed him, don't help them with the test, help them with the practice test. So don't try to fool them and say, oh yeah, Little Pro says we could do it. He won't buy into that. So anyway, but that's the thing. And then when I get back, we have one more week, and that's when we'll be going over the practice final exam. And I'll get you copies of that in advance. And again, I've got to check because I did some changes, so I've got to make sure I've got the right version of the practice test, but I'll get that and I'll bring it in probably about the same time I give you the final or the take-home test. So today, this week, and next week, we'll finish up all the content presentation, and then you have really a full 2 weeks to just kind of go through, start getting ready for the final, maybe review anything you didn't do well on before. If you've got a missed exam, we can work on getting those things made up, and just kind of keep moving forward. And you know, no matter how you've done on previous stuff, if you study hard and you do well on the final, always do this. If you get, because the final is comprehensive, so if you get an A on the final, even if you didn't take any of the other exams or didn't do anything, that's an extreme. Nobody's in that case, but if you were, as long as you get 90% of the exam, you got an A. Now, I've had students who tell others that they hear that and then they say, well, that means if you flunk it, you flunk if you flunk the final, you flunk the class. That's not true. If you have been doing everything along, you probably don't need that much on the final. You've already proved that you know how to do stuff, right? The other tests are an assessment, so you just need what you need. So most of you are in a place where by the time you get to the final, you'll have a B locked in. You will not do worse than a B. The final will give you those extra points to get you over into an A. And you don't have to get an A on the final to get the A in the class, but just whatever those points, you get a 900. but I'm pretty certain most of you will be at least 800, if not a little bit. Some of you might be very close to that border, and so I only need 2 points. Do I have to come? I said, well, yeah, because you don't get those 2 points, that's a B, right? So it's kind of strict, but just come, and it's multiple choice, so just, I just say, put all C's or something, but all A's, I don't know. You'll get something right, yeah? So, but again, this course is preparing you for what goes forward. College algebra is going to be very similar to that. So the better you understand this material, the better that experience is going to be for you. And when you get to college algebra, they're going to throw in a few more, like what we're going to talk about today with radicals. We're going to look at one specific type, but when you get to to college algebra, they look at many different types of radicals. And so, this forms the basis. The stronger your foundation is, the better that's going to go for you. Most of you are going to go on to some form of calculus, whether it's brief calculus for business or science-based calculus. And I'll tell you what, the hardest part of calculus is the algebra. So this forms a foundation. This will build that success for you as well in what we do today. Okay, so I'll just put this down. The word of the day will be 588. Just give you a little bit more opportunity. Again, remember, they're actually extra credit points. But we'll give you the option to do that. I was going to pull up the syllabus and show you the schedule, but we just sort of talked through the schedule. So do take a look, and it's pretty consistent with what's going on. We're right on track, and we'll make it all work. Okay. Any questions about the test? Oh, I just asked for questions, so I better pause and let you ask those questions, right? Any questions? Sure.
Is that the word of the day?
Yeah, 588 is the word of the day. I guess the number of the day. Numbers are words too, so 588. So we'll just do our little attendance quiz. So on the test, you can do test corrections and get half the points back easily. Actually, on some of you, I'll give you more than half the points, because some of you, the mistake you made is you forgot to put in a negative, like for one of the things. And I tried to grade them such that, well, that's like 1 point off, but you got everything right based upon what you put in, but you put that wrong thing in. So on this exam especially, if it's that kind of an error, you just put in the wrong number, but you wrote it down on the side so I could see it, and you drew the little graph so I could see the graphs going the wrong way. It should have gone the other way. Just rework it, put the new numbers in, I'll give you full points. Okay. Which again, if you get full points on this, even if you just got 100% without doing the extra credit, that's 52 points. Actually, that gets you 104% rather than, so it's a little bit better. I just didn't want to go into the decimals and all this stuff, so I just said, let's just multiply by 2. It's a lot easier. I could do that in my head. But multiplying by 1.9 was not very pretty and not worth the effort. So, and I didn't think you'd mind. Nobody minds getting a few extra points, do they? Okay, sometimes I get people, no, I won't. If I didn't earn it, I don't want it. Sure? Okay, I'll take them back. Oh, no, I'll take them. Okay. So it works that way. Okay, good. So let's go ahead and let's see where am I? Let's come back over here. There we are. I'm going to let's clear that up. There we go. Okay. 21. So just a little time to reflect, thinking back to all we've done. So how many of you feel like you've learned something so far? Good. I always hate when I ask that question, nobody raises their hands. It's like, oh shoot, we've done 9 weeks and you didn't learn anything. So good, you learned something. And hopefully you can look back and think, wow, we have done all of this. So we did quadratics, we did exponentials, so those have been our big function explorations. And then we did a lot of stuff on functions. When you get to 150, you're going to do exponentials as well, but you'll also do logarithms, so you'll be able to undo exponentials. So that's a new thing you'll get. Quadratics, you'll do quadratics of 150. What we're going to look at today is how to sort of undo a quadratic. So we're looking at the inverse function of quadratics, and then we'll look at one last function, which is 10, is rational, which are just if you have a variable in the bottom of a fraction. So those propose two different things. And again, you'll explore these in much more depth when you get to 150, but we'll take the time to go through and give you a good background here. So from the first part, I'm just going to go ahead and work through the workbook pages. I'll pull this part up, and as far as what's going to be important, just mark it up here. Okay. So here up from 9.1 to 9.4 is really background information. Okay. It'll be good to help you out for future on down the road, but none of that is going to be on my take-home test. And I think there'll be one thing possibly on the final, but we'll review it. Again, I'll go over it here, but don't worry about studying this part. So that's why I also allow you, if you do well on the test or if you do the practice test, I'll replace the homework, because there's all these homeworks that are helpful for you, and I encourage you to try them out, but I'm not so worried about for this particular class. I'll just be honest right now, that was really put in to prepare you down the road. So I'm not going to test you on it, it's not on the final exam, but what is on the final exam is this. Solving radical equations by graphing. Okay, so that will get you through. Now, 9.6 is a good skill to have. We'll do it algebraically. We'll look a little bit at it. But again, you can do everything if you just know 9.5. So if you're cramped on time, look at 9.5 first. Look at it deeply. That's what you'll need to know for the tests. And then there's some applications. Again, those will be helpful. That's what you'll be doing mostly in 9.5. But out of the whole chapter 9, if all you had time for was 9.5, that's the one you need to do. Because that's what will be on the take-home test. That'll be the primary part that's on the final exam. Again, there's one little question, but I think you'll be able to do it fine. When we get to review for the final, I'll make sure you understand that one. But you could also just say, don't worry about it. Because it's a lot of information for little return. I'll put it that way. Okay. So, anyone else like democracy? Or you prefer having what they call dictatorships? Anyone prefer specialists? Okay, so let's do a democracy. So since I gave you the information of what we need, where would you like to start? 9.5. Okay. Now, one vote for 9.5. Anyone else? You'll go for 9.5?
A little bit of the background information, maybe? Or no, we don't need that. Or we really don't need that.
We could get it, but again, maybe we look at 9.5 first, and then we can come back for it.
Okay, that sounds good.
Is that okay?
Yeah.
Because I'll tell you what, to understand 9.5, you actually already know how to do it. And I'll just show you. Hopefully my graphing tools will work good. But it really is, it's just graphing y1, y2, and finding the intersection. That's all there is to this section. So that's why I like to kind of start there, because it shows you right off the bat, this is the important stuff. Then when we go back and look at the other stuff, if it gets to be a little dicey, you're not going to worry about it. You're not going to stress. You say, we've already covered the important stuff for the test and for what we need to really understand for this class. Okay, 9.5. And then we'll come back and pick up all the tedious stuff, which are, you know, they're all in there in the, see, it's all this kind of stuff working. And I'll just clear this window. Where all this stuff comes, the background information, is when you're trying to get an answer in what they call exact form in mathematics. And typically the only people who care about exact form are math majors, if you're going to be a mathematician. So that's why I don't, you know, most of you, well, actually, is anyone going to be a math major? Someone's asking me, have you ever had someone become a math major? I've had people go to engineering, sciences, but haven't had the privilege of having someone come. And that's not my goal. It's not necessarily. It's I look at math as a tool as well. Okay. So most of this stuff is just to get answers that still have a square root in it. So it's again a lot of work for really small returns. And if you're in the real world, you want to get a number that is a real number rather than these kind of numbers here. Okay, but I'll show you just again, because sometimes you'll need to go through them. So this is all kind of stuff we can get past. The other thing is a lot of this is historically important because when we didn't used to have calculators, we couldn't handle these very well. Okay. Now that we've got calculators, we plug it in, we get a number, and that's good enough. We could go to 3, we can go to 10 decimal places if we want accuracy. But in the old days, 30 years ago, when I was going to school, you know, had to walk to school uphill both ways. You hear about that? But we didn't have the kind of calculators you have today. So all of this stuff is, I mean, it's good kind of mathematical stuff, but it's also, we can, oops, almost missed it. No, we don't really even need this stuff. We'll talk about this stuff, domain and range, but we'll talk about it in terms of the graph. Because as we look at the graph, it'll make a lot more sense. Okay, so this is really where we're going to start. If you can do this stuff, this is what's going to be on the take-home test. This is what's going to be on the final exam. It's solving a radical equation with graphing. Okay, so that's actually kind of where I like to start anyway. Okay, so what we've got is we've got an equation, and just like the breaking it down here, they tell us to graph both sides of the equation. Let y1 be one side of the equation, y2 be the other side. Okay, and they've even got this, they show it here, and they show the answer, find the intersection. Okay, so let's just do this one since we've got backup on it. Let's give it a try. Let me kind of see if my my grapher will work for me. If not, I'll have to go to the old school way of putting it on the overhead or the camera. So let's see. Okay, there it is. It's just slow. Okay, here it is. And it's a little tricky. So it's square root of 10 minus 3x. So I'm going to bring this over. It always gets a little wonky on me on here, so I will, let's see, how do I do this? I have to change the model. There you go. And I'll change it back. Clear this off. Okay, so we go to the button that says y equals. And our screen should look like this. And we put in y1, one of the functions. If I remember correctly, it was square root of 10 minus 3x. So we hit the second button, and the square root, it's hard, is that, see the x squared, above the x squared is the square root button. So it's blue, so you have to hit the second button. Now, if you have an older TI calculator, you might get a square root with a parentheses. So you'll just put everything in and then close it with the parentheses. The newer version actually has a square root thing, and as we start typing in here, 10, the square root gets bigger, subtract 3x. Did I get that right? Those who are following, okay. And then we just hit enter. And then in y2, we put the other side of the equation, which was 4. Okay. And then as we go forward in doing this, this is the first place we're going to come up and possibly have one issue, one problem. And then when we get to the next ones with rationals, it's got some other issues that we have to learn to deal with. So most of these two sections, the reason they're here is to get you better at using all the features of the graphing calculator. We're going to sometimes have to change the window, either zooming in or zooming out, and various things. Okay, so I'm going to show you the zoom key. For this one, since we're looking for one of them's y2 equals 4, the standard window should be fine, going from -10 to 10. So I'm going to go to the zoom, and I'm going to go to zoom standard, which is number 6. And what you see is you've got a window that goes from, x goes from -10 to 10, y goes from -10 to 10, and this way we both should see the same things. Now you'll notice this one's in color, which is nice, so you can see the two different graphs a little easier. If you don't have the color version, that's okay, we can still make do. Now, which one of these is the square root function? Red or blue? Blue, good. The red one is y equals 4. That's just a horizontal line. So the square root function goes this way. And is there anything in the square root function if we go to the right, like this way? Disappears. So I want you to understand, so we'll talk a little bit. This is like 9.3, and this is the best way to deal with it. The other thing I want you to be able to do is take a look at the table. And the table is the same button that the graph button's on, but since it's blue and above the graph, what we do is we hit the second button, and then we hit graph, and that takes us to the table. Okay. Now your table might be set up differently, so I'm going to go also with the table. I'm going second window, because right above that it says table set. I have mine starting at -5. And the table's changing by 1, and I have it set to auto. Okay, so those are the things I'd like you to have. It then will look the same. There'll be some times where we might want to change this auto to ask, but if it's on ask now, come down to auto, hit enter, and you've made it into auto mode, which means it starts plugging in x's at -5. It will change them by 1, and then we'll get this table. So here's this table. So here are these x values for these various x values. And notice with the blue, what happens after 3? When x is 4, what do we get? An error. Does anyone know why we get an error? What kind of problems do we have when using square roots? We kind of address this a little bit at the last part of the last test. There was
Imaginary number?
imaginary numbers, right? When we have negative numbers inside the square root, we get imaginary numbers. The calculator doesn't know how to calculate them, or at least not here. It certainly doesn't know how to graph them, because how do you do imaginary numbers? That's way beyond this calculator's abilities, so that's why we start seeing these errors. That's what you're going to face when you do radical equations. There'll be a place where everything beyond that is an imaginary number, so it's empty. It's like a river in the desert that goes underground. You don't see it again. It's someplace else. Okay, it just disappears. So in this case, where it's disappearing is from 4 on. Now, can anyone looking at this table, do you see any place where the y1 is equal to the y2?
2.
-2.
-2. You see another place? No, because then, see, this one's going higher. It's going to 5, and if you follow it, it's going to go up, but these go lower. So there's only going to be one intersection with these. So that's kind of how a square root function works. Once it starts going up, it keeps going up slowly, but it goes up. Think of it as it's kind of like a quadratic equation that's been turned on its side, and we've got half of it, because that's actually what it is. It's a U shape, but we only got half of it. Okay, but we can see it that the solution here is x is equal to -2. Okay, is that okay? So when we solve this, our solution is just x equals -2. I'm going to show you how to do it graphically as well, because we don't always get ones where it's going to show up in the table. Okay, so let me come back here. We're going to clear off this window, and then we are going to go back to the graph. So I'll just hit the graph button again, and now we're back to the graph. We'll do this graphically. Okay, so we're going to, how do we find the intersection? Anyone remember that?
Calc.
Calc. So this is, we go to second, the trace button, above the trace button it says calc. So second, calc. And we get this calculate menu. And remember, there's, like, if you're doing regression, there's a couple different calc menus, but this is the one we want. And what do we want to do? Number 5. So you could either arrow down or just hit the number 5. Oops, that didn't work. Why didn't that work? Who knows? So we just tried again. Go back to the graph. Second calc. Probably hit something out, and then I'll just do number 5. There, that's better. So it comes up, and our little spider guy, Spider-Man or Spider-Woman, is just sitting there on the graph. It's on the first curve, which is the radical. It shows us up here, and it's asking us a question, is this the first curve? What do? Enter, good, because we are on the curve. And I'll show you, we'll do an example where we get a little error problem, but we'll deal with that. Are we on the second curve? Yes. So we'll hit enter. For the guess, we'll just hit enter. It goes and finds that x equals -2, y is 4. Just like the table. So we can look up things with both a table and a graph. Now sometimes if this had been -2.2, we would not have seen it on the table unless our table was set up for it. Okay. So it's good to be able to use both tools and to confirm both ways. And in 150, you're going to be using both your table and your graph in these methods. Okay. You'll also be doing the algebra part too a bit, but this is the main thing. If you can do this, you'll always be able to find your answers.
So if you do this graphically, it can still be...
Yeah, yeah. And on the final exam, everything is multiple choice, so you just have to find the right answer. Right? So the methods are not important. But we'll show you both, and again, down the road when you get into calculus, sometimes we're setting you up so that you're ready for it. But that's basic. If you can do this. Now, again, some of these equations are going to be a little bit different, so we're going to look at a few things. There's a few things that does happen. We'll look at that. But if you can do this basic graph one's left and right side, y1, y2, find that intersection. You got this test done. Okay. Yes.
So funny. I did it like that and I grabbed it like that. That's still we can see right? It's an x2. That's 2x4.
X squared. Oh, that should be y2. Yeah.
Right here.
Yeah.
Y2. That
Right.
will be correct.
Sure.
Right? Thank you.
Yeah. As long as you get up with the, yeah, y equals 2. Oops, what's going on? Come on. Let's get back. So on this equation, basically, if you follow through, I'm on the wrong place. Here we go. So the answer to this, to solve, is just x equals -2. So just looking for the x. The y is where both sides are equal. So that's, but for our answer, we're just solving for x. Okay, so x equals -2. That's it. And what we'll do is we'll look at a few more examples, get you to practice that, and then we'll maybe look at a few algebraic ones, and then what we'll do is we'll reserve the other part, the earlier parts, the background information for Wednesday. Again, okay, so see, we're going to get a number of these. The equations can become more complicated, as in this one. And it could actually have a cube root. So this is where we might want to do some background work, again, to understand what a cube root is. But if a square root undoes a square, what do you think a cube root undoes? A cube. Okay, yes. So a third power. So that's what we use for the third power. I'll show you where they're at on your calculator, and then we'll see that the graph actually looks a little different. And then again, Wednesday, we'll talk about why all this is happening. But let's go ahead and take a look at this one. So we're going to do this one next. So what should we put in as y1? This side. Again, you could put either side, but we're going to put in the cube root 2x minus 1. And then in y2, we'll simply put in the number 5, because that's what's on the other side. Okay. We're going to get the graph. We're going to find its intersection of the two graphs, and that's going to be our solution. Sound reasonable? Okay, so I'm going to clear this screen. Here we are. And then pull up the calculator again. There we go. So we're going to go back to y equals. We're going to clear out what we had in previously and put the new stuff in there. Now, for the cube root, if you see, you should have a button that says math on it. Let's press that. You see this thing here, number 4? What do you think that does? Cube root, that's it. Now, you can actually do higher order ones. We won't have you doing anything more than a cube root. So, but if you did a 4th root or a 5th root or 27th root, we can use this one below it. But this is the one, number 4. So I'm just going to hit the number 4. And notice I've got now a cube root. It does something actually different than just the square root. And did anyone remember, was it 2x minus 1?
Yes.
Okay, thank you. 2x. This is why I like having two monitors. 2x minus 1. So now I've got the cube root of 2x minus 1. And when we look at the graph, it's actually going to look different than the square root. Because cube roots, you can have negatives inside of cube roots because it's an odd power. A negative times a negative times a negative is negative. and a positive times a positive is positive. So you can have both negatives and positives with a cube root. So you'll see the graph will show us that. What do we do for y2? I think it's number 5. That's all we do. So graphing y1, y2. We're going to go ahead and leave it at the standard window. So I'm just going to emphasize that by going zoom standard, zoom number 6. And that's what a cube root looks like. Notice its domain is all real numbers. It goes in both directions, negatives and positives. So this is what a cube root looks like. Do we see an intersection? No. Do you see that where maybe an intersection might be happening? Where would we need to go? We need our x to get bigger, right? We need to go more in the positive x direction. We're only going out to x equals 10. So how do we change that? Window is the easiest way to do that. And we can go to x max. So that's all we need to do is make x max bigger. From looking at that, do you have any estimate of what we should make it?
64.
64? Good. Because you have to jump out there. Some people go 20. I usually go 20, and that's not enough. So you just sneak up on, let's just go to 64. That's right, you're a computer scientist. That's why the 64, right? Or maybe just...
Well, actually, I did the table. I kept going down until I see the...
Even smarter. So yeah, we could use the table, so when you can't see it in the graph, you could go through the table. I forget about these things myself, but good. Let's try 64. Again, the thing is, if it doesn't work, we changed to 64. We actually don't have to either. But notice the graph is now way out here, and there it is. It's just barely making it, but it looks like there's an intersection.
63, possibly.
Yeah, 63 would have done. 64, 100 would have been fine. We just have to make sure it's on our screen. And then how do we find that intersection? Second trace button, which is calc. We get the calculate menu, and we want to do number 5. We're going to do this again and again and again. This is really the last 2 sections, pretty much all we need to do. We hit enter. The spider's on the graph. That's the first curve, right? So we hit enter. Did I hit enter? Uh-oh. This is okay. Look at what I got. I got some kind of answer here. I got the derivative. What's my problem? Can anyone help me diagnose what I did wrong?
Oh, we didn't do second or trace 5.
Yeah, I think I went down to 6. I hit the wrong button. So you got to be careful because it'll give you answers, but you got to make sure you hit the right button. So sometimes this happens. So I think I hit 6, which is actually a calculus type function. We want 5. We want the first curve, enter, second curve, enter, guess, enter. Now, what will happen is if this intersection was not in the window, say how you had only gone to 62, it will give me an error and it'll say, can't find, no sign change. Because what it looks like is it's looking for basically it subtracts both functions and it looks for it to go from positive to negative or negative to positive because that's where they cross. So you get this message, no sign change, and so you think, oh, does that mean there's no answer? No, it just means the intersection is not on the window. Okay. You want to see what that error looks like?
I had that happen.
You already had it. Then you figured out, just keep going. So yeah, when you get an error, it just probably you're not out far enough, so make your window a little bit more. Okay. But we've got our answer, x equals 63. Okay, and y is 5. And again, if we went to our table, we could verify that too, since it's a nice whole number. But we'd have to either arrow down for a while, or we can go back to our second table set. And since we know we need to be out at 63, we'll jump out to 63. We'll hit enter, and then go back to the table. So these are learning how to use the calculator is really what these 2 sections are about. If you can kind of go back and forth, see 5 equals 5, at 64 it keeps getting a little bit bigger, so and you could arrow up to 62, it didn't, so yeah, it was right at 63 where the intersection happened. So if you get used to going both ways, looking at the table, looking at the graph, and finding those intersections, you'll be fine. That's why sometimes if I get rushed for time, I do 9 and 10 on the same day, because it's basically, you're going to see 10 as the same thing. It's just that the graph has a few different problems, and that's all it is it's practicing using the graphing calculator to get our answers. And then we'll come in on Wednesday a lot more relaxed, because we'll say, if this stuff, if I get it, I'm going to be better down the road, but it's not going to hurt me if I don't understand it for this one. And I think that's what learning is about. Is sometimes it just takes longer to learn something than just learning and testing, learning and testing. So I want to give you the background, but for what you need to do in this class, this is it. Okay, so far so good? Okay, let's take a look at one more, and then I'll maybe give you guys some chance to do a few on your own if you'd like. And let's bring this up. So let's take a look at this one. This one here. So 41 plus 5, square root of this equals 11. So again, one side goes in as y1. The other side goes in as y2. We're going to graph it. We're going to find that intersection, and we're going to be done. But when you look at this y equals 11, what do you notice about where's y equal 11 going to be? Where does y equals 11 happen at? It's a horizontal line at y equals 11, right? Where does our standard window stop?
10.
At y equals 10. So if we want to see the fireworks, we better go a little bit further up. Okay, so we'll look at that. And that's one of the main things we learn in this one is how to set our windows. So back here, clear out the screen, and we'll go back to y equals. We'll clear this out. Clear. And then we'll clear out the 5. So it was what, 41 plus 5. And this is just the square root, so I can get to it right from here. I don't have to go to the math key for this one. There's just the regular square root. And what was inside? It was 2x. Subtract 4. And that was it, right? And then the other one was just 11. Y equals 11. So we got that put in. Again, I could just graph this. Why don't I do that? The thing is it's left over from the last one, and it might not be a very good window, obviously.
It doesn't work.
It doesn't work. Don't see anything. So what's the deal? Okay, let's go back Zoom standard. See if that does anything. The calculator's broken. Huh? How do I know the calculator's already done its graphing? There's a little wheel thing. Let's try that again. Let's go to y equals. Let's see, Zoom 6. Watch this. See that little wheel thing up there? That means it's graphing. When it stops, it's done. So it's no sense in waiting for half an hour because nothing's going to happen. It's done. It just, we can't see it. So the first thing is y has to be bigger than 10. Okay, so let's try that. So we go to the window, and what we want to do is we want to go to the y max. So this is because that's the top. We don't have to change everything. And what this is, you're going to find you're probably going to be better off just changing one thing at a time. So we want the y max. We want to see 11. So why don't we go to, what do you figure?
13.
13, 15, 20.
I did 15.
You did 15?
No,
50? Ooh. We could. But then sometimes you're too far out, right?
Yeah, but it's showing the exact.
But it's, okay. So sometimes there's also something called ZoomFit, but I'll just go to 15 because at least we can see it, right? 50 we'd be able to see it as well, but where's the other guy?
Far up there.
So that's why you went to 50. So see, sometimes you think you're going to be fine and you're not. So let's Let's listen to advice sometimes, little crow, right? 50, okay. But what I want you to see is this is kind of a trial and error. There's no right way. This is where math becomes as much an art as a science. You try it. If it didn't work, try something else. Oh, there it is, way up there. What are you thinking now? It's way up there. And where's it going?
It's still going up because I did was it Zoom 0,
Okay.
and it projected the whole entire thing.
So if we went up high enough, so we're not quite sure, go to the window. Let's go to 500.
It was like 96 or something like that. Matt.
Let's go to 200. Let's just really go up there. Let's be daredevils. Do you think these guys are ever going to intersect?
No.
So what would we put for this? No solution. It's possible that there is no solution. And this is one of them. That square root cannot get down below wherever it is, actually whatever that point was up there. And we could, and again, this is where it's helpful. We sometimes will understand more if we go to the table, even way out here. So you look at 61, it's at 95. Again, let's go to the window, let's go to the table set. Let's start it at 0. Okay, and now let's go back to the table. Error, error. So when it starts out at x equals 2, it's at 41 and it's just going up. Like, yeah, we're never going to catch it. Remember that one we did with the baseball over the center filters? There's no way he's going to intersect that baseball. And yeah, these guys are never going to meet. This is going up. This is staying at 11. There's not going to be a solution. That's a surprise, but that's possible. It can happen with all of these. There could be no solution. But if there is, we will graphically see it. So the key part of this is learning how to selectively go out. And what did you guys use? Did you use a ZoomFit?
I use Zoom 0 when I don't see anything.
Okay.
Get like a general idea.
And what is Zoom 0?
That's Zoom.
It's ZoomFit, I think. It's hit, yeah, ZoomFit. What it does is it looks at it, the calculator itself looks at it, and it gives you a lot of times it'll work, sometimes it doesn't, but there's this little extra tool. You hit ZoomFit, then you don't, yeah, that's not bad. You could see at least, I got 2 graphs and they're not going to intersect. Okay, so ZoomFit is a good little tool to use. Sometimes it doesn't get you to what you need, but sometimes it does. So far, so good? Okay, so that's that. Let's come back and what do you think? You want to look at any more? Or you want to try? Yes.
So what would be the answer?
Oh.
No, there's no solution.
Sorry, Charlie, no answer, yeah.
On the homework, if it comes up, it'll be like D&E.
Yeah, usually D and E for does not exist. That's what MAT121 really likes. Solution, we could just write no solution. That's another thing. Sometimes in math, if you've gotten into set theory, they'll do this, a 0 with a cross through it, which means empty set, means nothing. It's empty, there's no solution. So, yeah, MAT121, I think you're going to be asked to put D and E. Does not exist. Okay. Over here, we were able to put in x equals, what was our solution? Anyone remember?
63.
63. So that's what that answer looked like. This one does not exist.
So we only want the x answer, we don't want the y answer?
Right. The y answer is sort of the point where they intersected, but notice in the equation itself, there's actually only one variable x. So it's kind of like they're plugging in for the y. Good. Are you glad you started with this? Because it's good. And then this is solving algebraically. And again, the reason I don't really like doing too much with this is it's clear. There we go. is there's a couple different methods depending upon, there's 3 or 4 different ways depending upon how the equation is. And I'd rather, if you do it, and notice this first one, we can do them all graphically. And I'd rather you spend the time in this class working on that. When you get to 150, then there's some places where using the algebraic way is going to be helpful. And when you get to calculus, using the algebraic way will have some utility for you. But in this class, it doesn't. So what I try to get you to do is let's get that first step down of solving equations graphically using the table or the graph. So what I'd like to do is come back to this on Wednesday as well, just as a extra for those who are interested, and those who aren't can take off or put earplugs in or something and blindfolds if you don't want to see it. But I think it's something it's not too bad. Basically, we just square both sides. But the hard part is sometimes isolating the square root. But we'll see how that works. But really, to understand this, we have to go back through all the previous stuff to get that foundation. And that's what I mean, is using the tools we have to graph, I can teach you what we need. I can teach you how to solve this, solve a radical equation in 30 minutes. And I can make you almost an expert in 45 minutes, another 15 minutes. The other methods, the old school stuff, that will take a full day, at least 45 minutes just to get a foundation for it, and then a lot of practice. Okay? But I want to see you, I don't want to give you that first and get you discouraged. I want to show you the way to get the fast results because we have these modern tools. Let's use them, and then let's come back, and the other stuff will make more sense later. And it's not always needed. Remember, a lot of this is how math was discovered historically. But, you know, just because they crossed the country in covered wagons doesn't mean we need to go around in covered wagons to figure out what it's like. We can still go in our cars and do it on a day, right? So we have the tools. So that's where I'm going to leave it. Take some time to practice these ones graphically. And even in these units, you can go through, practice them, solving them graphically. And then Wednesday, we'll come back and we'll tie in the rest of the foundation stuff. But now that you've seen at least a couple of graphs, I think everything else will make sense. Remember, test corrections, there's no hard due dates, but just we're getting to the last, 3-4 weeks before finals. So get things in and we'll be in good shape. And when you do get the final, when you get the take-home test, the due date on that will be the day of the final, but you can also get it in earlier if you want. And a lot of you will be, you're probably all ready to do it, so you might go ahead and look in Canvas. In fact, why don't I do that? Let's see if it's already in Canvas. Oh, there it is. So where do I need to go? Here. Let's do this one. And I wanted to comment on the test. Those of you, most of you got down the interval we're increasing, interval we're decreasing really well. And I think, I don't know, maybe I did something right this time, maybe it was you guys, but it seems like I had this is like the best results I've seen. A few of you still had it mixed up. There was a mix up between using the X and the Y coordinate of the vertex, but at least you were using the vertex. But most of you, not only did you get the vertex down right, the X, but you got the directions of the increasing and decreasing down really well. So that was encouraging to me, at least. What am I looking for? Oh, I'm looking to see if we've got the take-home test already posted in here. And if it is, it'll be under modules. And that'll come up. And functions, exponents, resources, there's a final exam. So there's, yeah, if you wanted to, I think it's pretty much the same, but again, I'll check to see if they've done anything different with the final exam, but there's even some review videos if you wanted to get a jump on that. But, let's see, here we go. Exam 1 review, lesson 1, what happened? Am I even in the right place? Oh, this looks like Math 90. Why would I have, I don't know. Looks like I gotta do some work. Lesson 3, I didn't have much resources in here for you guys. Exponents, functions, combinations. Well, I've got some work to do. I will get it in there. I'm thinking I probably just deleted everything. I wasn't sure what I was going to do. But I will, I'll get the practice take-home test and the actual take-home test posted in here, and it'll be down towards this last part here. Final exam review. So just before the final exam review. Wait, oh, maybe. Well, I just have to keep going. I didn't realize that. Why would I have the final exam so soon? I don't know. I do crazy things sometimes. Oh, here's the quadratics. Here's the practice test. Here it is. So here's the practice test, and here's the take-home test. One of them's, they both say practice, but one of them's got to be the actual test, I hope. Oh, one's the answers, the practice test. One time I posted the answers to the actual test, and unfortunately I don't think anyone figured it out before I did. Here it is. So I guess I just got the practice test at this time. I'll get the actual take-home test posted there as well. But you can see the practice test is just solve these equations. Okay. A lot of these we haven't covered yet because these are actually lesson 10. These ones we'll do those next Wednesday or next Monday, and then these are the kind that we can solve. Okay, they're a little tricky, but do them and you'll be fine. And then this stuff down at the bottom with the vertical asymptotes, that's also part of chapter 10. So we'll do that next week. But there's these 5 problems that will also be on there'll be similar type problems there on the take-home test. All you got to be able to do is solve them. So if you want to pull this one up, and again, all the answers are x equals. Sometimes there's more than one, but most of these, there's only going to be one. There's an answer key there for them. Then again, I'll have the take-home test posted. Next week we'll go over these guys, see how to solve them, and we'll be in good shape. Okay. Sound good? Okay, so you'll get the rest of the class time to work through any of the other problems that you want to do, work on test corrections, any questions you have, and yeah, we'll call that a good day, and I'll stop the streaming. And what's the word of the day? 588. It's like a code. I don't know what it's called. 588.